Hello guys, today we'll be seeing about the concept of subroutines in the ABAP, because the concept of subroutines plays major role. This is one of the modularization technique which we discuss. Okay, this is also one of the modularization technique. One of the okay, one of the modularization technique. Okay, after this, code reusability. Like how we'll be writing the code in the function module. Similarly, we can write down the code in the subroutines also. So there will be a lot of logic which we can be write um, inside the subroutine, like how will be return inside the function module, like how we'll be having the importing parameter, exporting parameter. Similarly, in the subroutines also, okay, in the subroutines also, we'll be having the parameters also. In the concept of subroutine, we'll be having two different types: subroutines with parameters, subroutines without parameters. That means directly I can write down a logic without defining any parameters. For example, if I have any importing parameter and exporting parameter, so in those cases, we have to go for the subroutines with parameter. Okay, subroutines with parameter and without also. And when it comes to the classification of subroutines, we'll be having the two different types. One is the internal subroutine. Internal subroutine. This is the subroutine we created in this program itself. So we cannot use this subroutine outside of the program. So that is the internal subroutine created and used in this program itself. Program itself. This is the internal subroutine. When it comes to the external subroutine, okay, external subroutine. Okay, we created this program, but you can use that program in another program also. For example, if I define a subroutine in this program, if I have to consume the same logic in another program, you can call the subroutine in another program. You can do that. Okay. Create and reused. Create and reused. Okay. So these are the things are the basic introduction of the subroutines. The last point will be having the defining of the subroutine. That means definition. Definition of the subroutine will be having the perform. Okay. By using perform, we can define our subroutine. Subroutine name. Perform subroutine name. Similarly, the implementation. Implementation part, that is the by using the form our subroutine name. Okay, sub name. Okay, let me save it. Okay, firstly, we try to do the subroutines without assigning any parameters. Okay, so for that we need to include the let's include some set of logic in the subroutines without parameters. So firstly, let me define definition. So you can enter perform. Perform get data. Okay. From this subroutine, I want to get the data, and I'll define another subroutine. I'll written down some set of logic in that, because in the ALV reports also this subroutines plays major role. So that's the reason which I take up initially, because without understanding this subroutine, we can't able to do many things in the ALV. Okay. The next subroutine will be having perform display data. Perform display data. Let me save it. Okay. So we define the subroutine, but you can implement anywhere in the program. That doesn't matter where you defined. That's the matter. Okay. If I check the syntax, I define the subroutine, but I am not implemented that particular subroutine. Okay. So that's the reason it's giving an error. Form display data does not exist. Form means the implementation of this subroutine does not exist. Okay. If I double click on this, see the subroutine display data does not exist. Do you want to create? Yes, I want to create. So how? How you want to create a subroutine? See, the first option which we see, that is the new include. So this subroutine implementation of subroutine will create a new program, and we have to add in that. No, I don't want to create new program, new include for this. I want to written down this logic in my master program itself, main program itself. So in those cases, select the second one. Click on continue. Okay, now you can see. Okay, it will be added form and end form. If I check the syntax, okay, now you can see form get data does not exist because we are not implemented that. Okay, so let me double click on the get data perform. Okay, I want to include in the master program. Okay, so in this, I'm going to write down some set of logic in that. Okay, select material number 𝐸RSDA, 𝐸RNM. This is from the Mara table, material master into corresponding fields of table, LT Mara, okay, up to 12 rows. Okay, so the simple select query. Okay, let me define this LT Mara. Okay, data LT Mara type table of Mara. Okay, now if I check the syntax, I'm not getting any errors. Okay, and this, so we have to display, right? So for this, we need to have the work area ls Mara type Mara. Okay, let me save it. So now let me loop it. Otherwise, we already seen how we can display the data into the ALV reports, right? So let me call that particular grid display. Okay, reuse ALV grid display, right? Okay, in this, we are going to assign a structure name instead of taking the manual field tag. What's our table name? Table name is Mara. Okay, let me save it. After this, let me assign the field cat also. So that is the LT 𝐹cat. Okay. After this, let me assign the internal table, uncomment the exceptions. LT Mara. Okay. So let me declare the subroutines. Sorry, the field cat internal table. LT fcat type slash t field cat underscore al. This is the this is the table type. So now I don't see any errors. Okay. In the implementation of this get data, you will get the implementation. That means you will get the data into the internal table. After processing this, perform will be having the subroutine called as display data. So in those will be find out the sorry, you will get the display. Okay. So let me put the subroutine. Let me put the breakpoint on this. Okay, this is also one of the reusable statement. Okay, like how there will be some set of logic will be returned inside this. So we have to call, if you want to debug, you have to put F5. Let me execute this. Debugging will be triggered. So as of now, nothing. Okay, once we process this LT Mara, nothing. Okay, if we go for the F5 inside the subroutine, it will go to the inside the form. Okay, see, it will go to inside the form. Once if I go for the F6, so now I can see the data 12 records. Okay, if I go for the F6, it will come to the next subroutine display data. And again, if you go for the F5, see, now the cursor is moved to the display data. If I execute this, so now I get the data. Okay, so this is the way subroutine without parameters. But what if I have any subroutine with parameters? For example, I want to take an input, so I want to take that as a importing parameter, right? For example, we are written down the logic in normally, right, without consuming the subroutines or the function modules. What if I want to consume the same select queries in the inside the subroutine, because I have a selection screen where I design the inputs, right? So in those cases, I have to consume that particular parameter as an importing parameter. It returns some data how I can take in those cases. Okay, that is the concept of subroutines with parameters. Okay, now you can see that. So for this, let me get data mat. Okay, I'm changing the just subroutine name. Okay, here also I'm changing directly. You can change also. Okay, display data mat. Let me save it. After this, next one is okay, in the form also I'm getting the mat. Okay, similarly, instead of this, if you want to assign an importing parameter for the subroutine, so you have to use the concept of using. Okay, using is the importing parameter in the subroutine. For example, 𝑃𝐵𝐵LL, sorry, 𝑃Matner, right? 𝑃Matner type, what is the data element for it? Matner, right? Okay. User is giving this particular input, but I want to export some data, right? So that I could be displayed. So in those cases, like how we'll be having the exporting in the function module. Similarly, in the subroutine, we'll be having the concept of changing parameter. Okay. Our internal table LT Mara type. So see, whenever you take the type, so it should identify the table type whenever you want the internal table, right? So that means you have to create a table type for the Mara structure. So almost 90% of the cases, the table type of the table will start with TT underscore that particular table name. For example, I don't know whether that exists or not. TT Mara. Okay. If I double click on this, let me see. We don't have. Okay, let me check what is the standard table type which we will be having. Let's see 11. Okay, so in this TT underscore Mara, if I check it, see does not exist. Sometimes it's happened. Mara, okay, put the star F4 table types. Okay, for this, okay, let me check this. Go for the display. This is the table type, and again, this is the structure. So if you have almost the similar structure, okay, let me copy this and paste. Okay, paste instead of TT underscore Mara. Okay. If I check the syntax, see, get data for, but we don't have any parameters in the this next subroutine. Okay, that's what it's saying that. So different number of parameters in the form and subroutine, number of formal parameters. Okay. Okay, for this, we are going to have define a parameters for this also, because we are not defined, we are implemented in this, but this definition part, we are going to include this in the, not in the implementation, in the defining of the subroutine itself. We have to define this, not in the implementation. Okay, let me remove it. Okay, so let me include this here. So now if I comment out all this implementation, because once you add the subroutine, there will be a different kind of parameters also added inside the implementation also when we create an implementation. So for this, let me double click on this. Okay, perform get data material. Otherwise, let me change. Let me save it. Double click. See, material does not exist. Do you want to create the object? I want to include in the master program itself. Okay, now you can see. Okay, using P material type, P Matner, LT Mara type, that is the changing. Okay, in the implementation part also added. You can take this as in the function module, whatever the parameters which you define, when you implement that, you will receive in the sub implementation of subroutine itself. That's what it's saying. Okay. So whatever the logic which you want, you can put inside this subroutine. Okay, let me copy this and paste it here. So instead of restriction of rows, let me include the parameter mathner equal to p mathner. Okay, so for this, we are going to have the next is, let me implement the implementation also. Okay, let me save it. So double click. Sometimes it does not show. In those cases, you don't need to be double click. And the only thing which you have to do is, okay, directly you can written down the manually. Okay, written down like this with the subroutine name itself. Okay, form will be having the info. Okay. Okay, as of now, we are not declared that parameters p mathner type. What is the data element for the mathner? MATNR. Okay, so it's saying that type is unknown. Okay, let me see what's there in it other than the type. So why it's saying that is unknown? So let me check. Do we have any other errors? P type is already declared. Okay. So let me remove all of this because these are the extra parameters are added. Let me remove this. Okay, here also. Let me check this. Type is unknown. Similarly, it's seeing this. Changing LD Mara, why the type is unknown. Okay. So we don't need a type for it because it's automatically taking from the declaration. So I initialize the type also. Type it is not accepting unless or until it will be a complex type. Okay. So for that, let me activate this. Whenever you use the separate include for the implementation of subroutine, okay, this is the way how it could create. This could have only the implementation of that particular subroutine. Okay, so let me save it, check the syntax and activate. Go back. Let me check the syntax. Now you can activate. So now whenever you use that, you will get this include program inside your program, main program. Okay, so now we don't need this because we already consume the same logic in the this subroutine. Okay, so let me activate this, execute. So firstly, we have to check p material one. Debugging is triggered. If you go to the inside, it will go to the inside subroutine. Okay. If you go to this is the material which we passed. As of now, we are not getting to LT Mara. Okay. If I go for this, I'll get one record. If I execute this, now I could see that in the output level. This is the way how you can consume. So we are consuming the parameter, right? In the importing parameter in the subroutine. Similarly, you can consume select option, like how I given the task to you and we discussed the function module, right? Similarly, you can consume the select option as an importing parameter in the subroutine. Okay, so this is the extra task for you. Okay, this is the one. The second thing is you can explore, you can define a subroutine in one program, but you can call that subroutine in another program. This also you can try that. Okay.